Good morning, all. Waiting for Jan to join this morning. We've got some good stuff to show around how we're generating Sql. So this will be pretty exciting, I think, and pretty helpful for Jan in particular, but anybody else who might want to join me in developing an immutable runtime. Yeah, as we're getting started this morning, where we are in the project, I am working on Janaga.js on the server side, and adding a new capability in terms of a query language. And this query language can generate multiple SQL statements that each produce different sets of facts. And those facts taken in aggregate will produce a graph that gives you all of the evidence you need to answer a specification. So there's a lot of information that goes in, even if the answer that comes out is refined and filtered and projected. It gives you all the information in order to do that projection on the client side. And it does that in such a way that the client can progressively come back to the server and ask for new information, new facts that have occurred since the last time it asked for that information, and that will impact that specification. Good morning, Jan. Good afternoon.
Good afternoon, Michael. Yeah, I always have the impression that time goes faster here than at your side.
Yeah, that might be the case. I don't know. I do tend to be kind of laid back, and even though things are just racing past, I'm just kind of like, keeping up with them and just doing what I do.
I try, but I'm not always successful. No. Okay, it's a quarter before 3. I say, okay, I still have a little bit time. And the next time I looked at the clock. It was 3 o'clock. I said, oh no. Yeah.
Yeah. So we heard from Caden. He's not going to be able to join us again today. Very sad to hear the news.
Yeah, I just saw it. Yeah, his father passed away, if I read well.
Mm-hmm. Yes. Yeah. Not. Not something that I myself can truly understand yet. I've been very fortunate. So.
Me too. So far, so good.
Mm-hmm.
Yeah. I saw your rework of the video.
Yeah. Yes.
which was quite funny. It was like time travel.
Yep. Yeah. I opened up my Mac, so that was all screencast from the Mac, and I was like, well, the editor is still here. Yeah. Command Z. Oh yeah. I can go back in time. So just Command Shift Z and just let it redo all of the edits. And so it looks like I typed just a whole block at once. It's like, boom. So yeah, that was
if you watch it now, everything goes fine, and then at once panic because the stream was not. Then you say, oh, I forgot to switch on the stream.
Yeah.
which is not true.
Yeah, it's been right there the whole time.
Yeah. But okay. So you wanted to explain me a little bit how to proceed with the query portion, if I got it right.
Yes. So let me make sure that that I turn on. I transition to okay. Yeah, there we go. That one's actually a little bit better view. All right. Okay, so first of all, what I've done in the past week is something that turned out to be much simpler than I thought it would be, and that is to get the order by of the bookmarks working so that I could then do the paging. So all of that is now working. I just refreshed my my database here for the sample application. So here we're looking at the Improving You application running on my local machine, and so I've filled out a few courses in Dallas Fall 2021. I've got 4 courses in there, and you can see right here what I've done is I grabbed config.js, which is something that's generated on the server side that gives you the starting point. So here's the company, and then it is from the user. So this is the public key that I generated just now when I set up the database and logged in for the first time. So then I took that and pasted that public key into the interactive application. So now we can run the queries against that particular company. And this actually kind of surprised me a bit. I had recently changed the well, not too recently, but I changed the library that I was using to generate key pairs. The one that I was using before had a pretty significant flaw. It was generating weak keys. But now I'm using NodeForge, and it's pretty good. But as a result, before it said, the old one said RSA public key, the new one just says public key, which I think is kind of interesting. But at any rate, if everything is working, I should be able to do npm run build, make sure that I've got all the source code built, and then I should be able to do npm run interactive, and I should see some results. Nope, I don't see results. Oh, fact type course delete does not exist. Okay, yeah, that's a use case that I haven't solved for yet. Yeah, let me do that first of all this way by taking out the query for course delete. Another way that I could do that is actually just to go over here to the application and delete one of these courses, and then I will say, oh, there's a new fact of this type. And then course registration does not exist, so let's not do the registrations quite yet. Okay, and the graph is not connected because I'm asking for users, or I'm giving you users, and there's no registrations for them. Okay. And now, all right. This is actually the first clue about what I did in order to make the bookmark work. So you've got right here order by bookmark, and I've got a limit, so I can pass in that limit as a parameter. But right here, order by bookmark ascending. What is the bookmark? The bookmark is defined up here. So in Postgres, you can create an array as a first-class data type. And so I'm creating an array, and the elements of that array are the fact ID of F2 and F3. So those are the 2 labeled facts in here, the cataloging course. F1 is the semester. So I put that into an array, and then I call sort. And I sort that array descending. And so that gives me the bookmark. And now that's an integer array. I can order by the integer array. And surprisingly, it did exactly the right thing. where it ordered by the first element of the array first, and then where they were equal, take the second element, where they're equal, take the third, etc. And that's precisely the ordering that I need for bookmarks. But there's a catch. The function sort is not a built-in function. It's one that comes from an extension. But fortunately, that is an approved extension. And so let's see if I'm going to be able to start pgadmin. I think I had trouble with this last time. And what we can do is just issue a simple command to install that extension. And pgadmin is okay. There it is. So that might not start. We've had trouble with that in the past. But the other thing we can do is PSQL. Yep, okay, so if I do PSQL, then the .h is localhost, -u is Postgres, and then I attach to the database improving you, and then the password is the password that I used in order to create the Docker container, which we can see right here is the improving UDB. The Postgres password is secret PW. Okay. Secret PW. All right, so now I'm in the improving you database. Yeah, pgadmin's not going to start up for me. All right. So the secret incantation is create extension int array, if I remember that correctly. Yep, so that created the extension. And so it's an extension that's in the box. So when you create the Postgres server using the Docker container, it's already there. You just have to enable it. So, so now in my script, I do enable that, but I have to build and deploy that script. So the one that I just did this morning doesn't yet have that. So now I was back on. Yeah, that's right. Yeah, back on this one. So let's hit save, try that again, and yay, it works this time. All right. So now you can see that the bookmark is ordered from greatest to least, and furthermore, I'm getting just 1, 2, 3 tuples, and that's because right here in my little interactive application, I say I want to limit to 3. So that is doing the appropriate limit, doing the appropriate order by. And so now if I were to run the same query, but here I pass in a bookmark that is 25.8, then it will get the next one in that case. There's only 4 in the database. Okay, so progress is happening there. So let's see what all that progress entails. I will start with the tests, because I find the tests are an easier way to kind of introduce what's happening. So we'll go to the Postgres tests. So here's the old tests for the Postgres adapter, and so here's the one that uses specifications. So adding this new capability in parallel, and then after a few iterations and everything is switched over to this new specification, then I will get rid of the old capability. Okay, so let's switch to where we're running these tests. So kill that, npm run test, and it runs all of the specifications, well, all of the spec as in the test spec, and everything passes as it should. So the first test right here, the Postgres query generator, should generate a join to successors. So it started off pretty simple. In fact, the interactive that we just ran is just one step more complicated than this. But starting at a given predecessor, then we're going to match successors of type integration test successor, such that successor predecessor being a root is equal to the predecessor that is given. All right, so first of all, the SQL that it needs to generate in order to make that happen is that it needs to produce a set of tuples. So in this case, the tuple has only one fact in it, the successor. And so the way that it's going to produce that tuple is it's going to get the hash of each of the facts within that tuple. So it selects f2 hash, calls that hash2. It doesn't need to select the type because before it runs this SQL, it has already looked up all of the types that appear inside of this specification. So now it knows the type ID of root, it knows the type ID of integration test successor.
So these types are cached in the software?
Yes, exactly.
Okay.
Yep, so on first run, it loads them all from the database, but subsequent executions, it already has them in memory, so it just uses those IDs.
Yep.
And then, and so yeah, the type and the hash are sufficient to create the reference, and that's all that we want to return from from this particular SQL query or this particular request. So we've got the hash, but then we also create the bookmark. So so here's where it creates that sort that we just looked at, and it puts each of the different fact IDs from the tuple into that array. It sorts them descending, so the most recent fact is the first one, and then that is the bookmark. So now it's got fact F1, which it uses in the where clause. So so it knows coming in that the type ID is the ID of root, and the hash is the hash of this particular predecessor that's coming in. So the way this SQL 4 works is it sets up some code. It sets up the scenario to run this, including specifying the root. So so we have those things coming in, and so now we know what F1 is, and so then we begin to join on edge, and then back to fact, and then back to edge, and back to fact, as we zigzag our way through the query, the graph. So in this case, since we are taking a successor step, and we can tell that because we look at the the arrow is on the left hand side. So starting at the successor, look up to the predecessor, And so it says, okay, well, I have the predecessor, so I need to take a successor step. So that means E1 is joined to fact ID to fact1 via that's the predecessor, and then it also constrains it by the role. So the role being the type of successor, and the role name. So integration test successor, predecessor root, or predecessor is the role. So then it's got E1, and now it can join to F2, that being the successor along that edge. So that's the kind of query that we are looking to generate. And this one is a pretty simple one to start with. They of course get more complicated. So as you add more arrows on this side, you get more joins of this form, where you join to the predecessor first, and then the next fact is the successor. When the arrows appear on this side, then you've got successor fact ID here and predecessor fact ID there. So you walk it in the opposite direction. And then we'll get into the existential queries, which end up as where clauses, where not exists or where exists. Actually, we don't generate where exists. We only generate where not exists. So I'll get into the reason for that. So let's take a look at, dive into SQL 4, so we can see what the interface looks like. Yeah. So first of all, parse that specification. We earlier looked at how you can type in that specification text, and then that gets turned into a JavaScript object. I don't think we walked through the parser there, but we'll, if we need to, we can cover that another day. But right now, this is a specification that tells you things like, these are all the givens. These are all of the matches, with these being the unknowns, and then here are the steps that are taken on the left side and on the right side, and that sort of thing. And then it just scans for all the fact types, gets those fact type names, and here it just generates a fact type map, where it just puts numbers in there. So it's like, pretend that you loaded this from the database. Same thing with the roles, get all the roles that appear in the specification, and then add those to a role map. And now you've got the same sort of thing that you would have loaded from the database. Here I am setting up for some future tests where I can have a type called unknown or a role called unknown, and it's going to skip those. It's not going to put those into the fact types or the role types, and that will help me to test the scenario that we just ran into today, where I'm specifying a query for that includes a role or a fact that doesn't yet exist. So then we take all the givens, and so now we're looking for root or Janaga user, and this is where we've got the user and the root just kind of hard-coded in there as these are starting points that we can use for these queries. And so if you happen to see those in the givens, then okay, make those part of the start. That way the start always lines up with the given. So now this is where we actually hit the code under test. So we're now looking to generate SQL from specification. So give it the start, give it the array of bookmarks, the limit, how many tuples do you want for each of the different feeds, and then the fact types and the role map that we just generated here.
Why is it an array of bookmarks?
Yes, good question. So in this case, if we scroll back up to this result, we only had one feed, and that feed was the feed with catalog course. If I had the existential condition in there, where not exists the delete, then I would get two feeds. One would be the catalog course delete, the other one would be the catalog course. So that first feed, catalog course delete, would be, here are all the course deletions that occurred in this catalog. And then you get no other information about those courses, just the fact that they've been deleted. And then the second feed, catalog course, these are all the courses that are not deleted. So because you've got multiple feeds, and each feed has its own bookmark, we pass in an array, which is for this set of labels, catalog course, the bookmark is 25.8. And so it is going to generate the SQL, not execute it yet, but generate the SQL and all of its parameters. So it's going to take the bookmark from this array and put that into the into a parameter so that it ends up in the right place. It's also going to take the limit here, 100, put that into the parameters. So by the time we get done here, we have our SQL. We've got an array of parameters, and then the set of So this is the list of labels that are produced by that particular feed. Yeah, so this is one feed. So here's the SQL for that feed, the parameters that go with that SQL, the labels that feed produces, and the final bookmark or the starting bookmark for that query. And actually, because the bookmark is part of the parameters, I might not need that anymore, but we'll get there. Okay. So yeah, here I'm just testing the this gives me back that array of SQL queries, so one for each feed. So we're going to test that set of SQL queries, and we need the fact roles in the role map in order to do that test. So we need to validate that the parameter at array 0, which is actually $1, yeah, right there. That should be the fact type ID root. So that's saying the root. That's the root hash. This is going to be the role in the fact type integration test successor called predecessor. And so that'll be the third one, so $3 is that particular role ID. And then $4 is 100. Okay. So now we get to actually dive into SQL from specification. Oh, it's only 3 lines of code. All right, the big one right here is generate SQL query. It's doing that by creating a description builder. So that's a class that kind of keeps track of some. It's kind of like a workspace class. So we started off with the fact types and the role map. So it's like, oh, hold on to that. You're going to need that for just about everything you do. And then we tell it to build the descriptions. And then we go through the descriptions and we tell them to generate SQL. So let's start with, what is a description? So a query description is a whole bunch of information that we're collecting about a query. So you can imagine taking this information and turning it into SQL. But yeah, we want to gather the information first, and then we can generate the string. So we've got descriptions for all of the inputs. We've got the parameters, descriptions for all of the outputs. So in this case here, yeah, the inputs are predecessor root, and it goes into a little bit more detail because it says, oh, okay, I recognize that that predecessor root is the first one. I'm going to allocate F1 to be predecessor root, so that's the fact index. And then I also know that I need to allocate a parameter, so I'm going to call $1 the type of that fact, and $2 the hash of that fact. So it keeps track of all that, and that's how it generates the inputs. For outputs, there it's saying, okay, I recognize that now you are looking for something labeled successor, so I'm going to call that an output, and I'll allocate F2 to that.
Yeah.
So keeps track of that. And then it's keeping track of facts and edges. So so every time we take a step, either a predecessor step or a successor step, we're going to record an edge, and then if we haven't already visited that fact in the graph, we're going to record that fact description as well. So now each of these edges join those different fact descriptions. So the important thing here is you end up with a fact description for every fact table. Some of those are inputs, some of those are outputs, and some of them aren't labeled at all. They're just steps along the way. So they all get fact descriptions, but only some of them get input descriptions and only some get output descriptions. And then an edge joins one predecessor fact to one successor fact, and then has a role associated with it. And we'll get into the not exist conditions in a bit. So, so let's talk about how we gather all that information together. So, there we are. Okay, so let's go to the description builder and build some descriptions. So it's going to do a little bit of type checking first, just validate the data structure that it's given, make sure that everything lines up. This is not the entirety of the type checking that I want to do here, but I'm going to test drive that. I'm going to create tests for the failure cases. And so the first thing that it actually does is goes through all of the different givens from the specification and turns those into input descriptions. So it captures the label, it allocates a fact index, so all the givens start at 1, it counts through those, and then gets the fact type ID. I've got these enforced versions of it because I suspected along the way that that it wasn't finding the fact type. Turns out that wasn't the case, but I wanted a version of get fact type ID that rather than return undefined through an exception. But yeah, that's basically, let's get the fact type ID from the fact types, the hash, and then the type parameter and the hash parameter will be filled in later. So right now we don't know, we haven't allocated a parameter to go along with those particular inputs. And there's a very important reason for that, which we will talk about. Then go through the givens again, and this time we allocate fact descriptions. So now we've got the same fact indexes that we used here. So this is F1, F2, F3 for the various inputs, and so now we've got a fact description and an input for every one of the givens. And that's how we start our query description. Now you'll see a whole bunch of empty arrays here. Query description is an immutable data structure. So as we build a query description, what we do is we take an existing query description, produce a new one that has all that information plus a little bit more. And the reason for that is that along the way, we're going to say, oh, I just recognized I need a new feed. Here's the query description for that feed. Go down that branch. But then starting with that same query description, go down a different branch. So each of those two different branches gets to build on that starting query description in their own way without mutating it, so it doesn't affect the other branches.
Yeah.
Okay, so real quick, the things that it's populating in there. Yeah, actually, we did go through those. So the empty arrays are the other things. So we're populating the inputs and the facts, but then we've got an empty array of parameters, outputs, and edges. And not exists where classes. Okay, so now let's add some edges. So we are going through the specification matches. So a match is essentially this part of the specification. So it starts with an unknown, and then it has a series of conditions. And so this particular type of condition here is a path condition. So it walks along a path on the left side and on the right side, and joins those together. The other kind of condition is an existential condition. So we're going to walk through those matches. We've got the conditions within those matches. If they're path conditions, we go down this path. Existential, we can again talk about later. But then adding path conditions, this is where we now have the starting query description, and then the path condition itself, plus a couple of things that kind of give us context. The most important one here being the unknown. So the unknown is successor, integration test successor, and then we've got that particular path condition that we're looking at. And we'll talk about this one in just a bit. The one of the rules about this specification language is a little bit more strict than what's available in Janaga.net, and that is that the symbol on the left-hand side has to be the unknown. The symbol on the right-hand side is any previously defined symbol. So it could be an unknown from a previous match, or it could be an input, a given. So here we're checking to see, does the label on the right match an input? And so if so, then it's going to, and that happens to be the very first input, then it's going to generate an input parameter. So there's there's a reason for it only doing that for the first one, and that is that for the remaining givens, we want to hold off until we actually see that that given to generate the fact. Or I'm sorry, the parameter. And so the reason for that is that if you have a parameter that is only used in certain conditions. So let's get back to, oh, actually it was in this one. But I closed it out. So let's go back to this and this here. Yep, and roll that back so that we can take a look at that specification as it used to be. Okay, so this is before we deleted this existential condition here. All right, so as we're parsing down this, we've got our catalog label and our course label. So these are both matches. These are the paths within the match, or the conditions. So that's a path condition, existential condition. We read the existential condition and we say, okay, I need to now emit a feed that that includes catalog, course, and delete. And so that feed does not use user. User is taken into account later in the specification. So if that feed included the user hash as a parameter, then Postgres would be very upset. It's like, you've given me a parameter that doesn't appear in the SQL. So I don't know what to do with this. So we hold off on all of the subsequent givens until we see how they're used. And then we'll go ahead and inject that parameter. But the first one, in order to make sure that the SQL always generated correctly, it always it assumes that you're going to start by using that very first parameter. So this is going to be one of those structural checks that I put in there. So if I were to express these in the opposite order, user first and then semester, but I'm using semester first, then the SQL that I generate would be invalid. So just wanted to detect that scenario, either raise that as an error, or figure out a way to just reorder things so that it works. I could just reorder the inputs in order to say, oh, that's the first one that you use, so I'm going to make that the first input. Okay. So this is the first time that we saw one of these with methods. So remember, the query description is an immutable data structure. So these with methods are ways to produce new query descriptions from an existing one. So give me back a query description with this label.
Yeah.
And so what it excuse me. What it has to do is allocate a fact type parameter and a fact hash parameter. So it goes to its list of parameters that it's already allocated, and it says, all right, the next one is the fact type, and then the one after that is the fact hash. And then goes through its collection of inputs, finds the input with that label, and then it's going to concatenate the fact type ID and the fact hash to the parameters. So it's got that information coming from inputs, and then this is where it Yeah. So this is where it actually adds the input to the query description. So up until this point, we haven't had those inputs within the query description. So at the beginning, we allocated facts for each of the inputs, I believe. Let's go back to the beginning where we where we first created. Oh, okay, we're still inside of there. Lots of writing of SQL. Where we first start build descriptions. So we generate inputs and facts. Wait a second. This might be some old code competing with new code and still just working by accident. With input parameter for this label, the inputs that we have here, okay, I got it. All right, so yeah, we're starting with these the inputs that we were given. These are the ones that we generated to begin with. By doing the map, this is reaching into that array, finding the one with the matching label, and when it finds it, then it sets the parameter indexes. So this is the index of the fact type parameter and the fact hash parameter. And for all the others, it leaves them unchanged. So this is basically modifying an element of an array, but doing so in an immutable way.
Getting pretty complicated.
Mm-hmm.
This is going to be one of the recordings I have to review.
Yeah, I think so. Yeah, so if I go back down to where we got started, right here where we generate those input descriptions, we leave fact type parameter and fact hash parameter as 0. And so 0 is the indicator that that we don't want to emit any SQL for that input. But then if we have a non-zero parameter index, then we emit the SQL that as a part of the where clause that looks for that particular fact type and fact hash. Yeah. Okay, so that's how it goes back and fills in those values. But by fill in those values, it makes a copy of that array, essentially, with those values filled in. And that gets you to... There we go. That gets you to a query description that has that particular input parameter filled in. So now the fact type and the hash have been added to the parameter array, and the indexes have been set inside of the input array. Okay, so now we continue through this path condition, and so we are looking at just one condition like this, and we have an unknown from the match in context. So we're trying to see, does this particular query description that we're building already have an output for that unknown? If not, if it does, then we get that known fact. Otherwise, that comes back as null. So this fact by label, that's just looking inside of the inputs, and if it finds the, let's see, why is it looking at the inputs again? Yeah, so if it doesn't find the input, and it doesn't find the output, then it creates a okay. If it doesn't find the input or the output, then it just throws an error, right? Okay, it's doing some type checking in here. Yeah, yeah. But this is the real work. So we're going to look for either the output or the input that has that particular fact index. So. But why the label? Okay, yeah, so here it's looking for the output with that label. Right, okay, look for the output or the input with that label. That gives you the fact index. And then you're looking inside of your facts, the fact descriptions. Remember, there's a fact description for every fact that you visit along that path. Some of them are inputs, some of them are outputs, and others are neither. So, yeah, so we've got a label that could be an input, it could be an output, and we're just looking for that that fact within that that collection of facts that we have visited. So, the point being that we are writing this path condition. We are looking at the unknown and trying to find its fact ID. So if we have already written out that unknown, then we just want to continue to join from it. But if we haven't written out that unknown, then we need to write it out and then start the joins. So the condition has two different sets of roles on the left and roles on the right. It only has a label on the right because the label on the left is assumed to be the same as the unknown. So we go through all the roles first on the right because the symbol on the right is the one that we are starting from. And so we're going to do, from there, a series of predecessor joins. So we get the fact type ID and the role ID for that particular edge, and then we add that role ID as a parameter, and that gives us back the parameter index and a new query. Now this is a query with parameter, and then we add the edge. So given that role parameter that we just added to the collection, create an edge from this successor fact index. I'm sorry, that predecessor fact index to that successor fact index.
Yep.
And that's only if we have this this known fact, and this other part of the condition. This has to do with when we're deep inside of existential conditions. We don't want to we want to do things a little bit differently. But so you've added that edge and you've taken that step. So now the next fact index that you're on is this next one that that you just stepped to. But that was a known fact. If this fact is unknown, so you haven't written out a fact index yet, then first you do with fact. So that allocates a new fact join and gives that a new number, and so that's your predecessor fact index. And then you do the with edge. So take that that predecessor fact index from that new that fact that you're starting with. Use that role parameter, same role parameter you allocated up there. So here you're adding a fact and an edge, whereas this first one you're just adding a fact or just adding an edge because that fact was already part of the query.
Yeah.
And so you go through everything on the right side, and so you're stepping, basically you're starting your fact index at the label, and then you are stepping up through each one of the different predecessors, and by the time you're done, the fact index is the one that you're is at the tail. So if you've got a bunch of arrows here, you've allocated facts and edges along the way, and now you've got the fact ID for the one at the end. And then you have to go to the left side and go through those. But the trick is you need to reverse those edges, because from the left side, you're starting with the unknown that you're just now trying to define, but that's really the place where you want to end up. So you walk through these predecessors in pretty much the same way and generate a bunch of edges, but then you have to reverse those edges before you add them to the collection.
Yeah.
So that reverses those edges, adding facts along the way, adding the parameters along the way, just like we saw. And then when we're done here, if we do not yet know the fact, the unknown that we just landed on, then that's when we allocate it as an output. So in this case, here catalog was not an output until we got finished writing out this path that gets us to the catalog, and then we say, okay, that's an output. Make sure that's part of the select. If we were to have another path condition just below this one, then that would already be a known output, and it wouldn't add that to the select again. It would say, okay, that one's already there. We're just adding more conditions to further constrain it. So that's about as far as we'll be able to get today. There's a lot to it. But the secret was test driving my way to it. So I said, okay, this is what the specification should look like. And I know that the structure is going to be some kind of a workspace and an immutable data type that that keeps track of things as I build them. And then starting from that rough sketch, I just said, this is the SQL I expect, and let's iterate on it until I get that SQL.
Yeah, I feel like an CPU in overflow. Too much joins. No, it's rather amazing code to get to that result, but
yeah, this is the most sophisticated code I've written in a long time. That's for sure. And we just got finished writing a query provider for LINQ, and so that was pretty sophisticated too.
Yeah. But so in fact we have to use the same interface language, and then because this is the moment that it gets the interface language from the client, and it translates it to SQL.
Yes.
But on the client itself, if it goes to the local database, I'm not going through the step via the interface language, am I?
Yeah, you don't need to produce this text along that path. You will when you talk to the server, but and you'll never need to parse this text. So, but you will have a data structure that is pretty similar to the parsed version of this text, and And so you'll want to use that data structure in order to generate SQL that you're going to run against SQLite. The difference is, because you know that you are the client and you're interested in everything that this is returning, you don't need to have the order by and the limit, and so you don't need to have the bookmarks at all. So even if SQLite does have this order by int array thing, yeah, you're not going to need to take advantage of it. I was very fortunate that Postgres has it. Yeah.
I don't know whether SQLite has it. It might, but I guess it will not.
Yep. Not going to be important. You're going to want everything that's in the database. Yeah, and then from that point forward, so that's basically, you start up the application. Here's a new specification that hasn't been run before. Let's go ahead and run it against the database. Load memory with it, and from that point forward, now you're taking that specification and you're sending it to the server, and you're periodically, pinging the server, or you're setting up a WebSocket or something to get the results. But as you get results back from the server, you write them to your just SQLite database, and you run query indexes, and you put them into your memory cache, and you run the query inverses in order to update the user interface. You never have to repopulate your in-memory cache from your local database. So that means that that the bookmarks wouldn't do you any good. You're not doing that query multiple times against your local database.
Yeah. Yeah, that's going to be a difficult portion.
Yeah, so that'll make it just slightly easier. Not a whole lot easier, but just slightly easier.
I think I'm going to first try to understand it, to fully understand it.
Yeah, but I think the things that will help to understand are the fact that the query description is an immutable data structure, and so that's why it's doing things slightly more complicated in order to map over an array and give you back a copy of the array. So as you see how it now creates different branches, and it emits a query description going down this path for an existential condition, but then takes that same query definition and goes down a different path to continue the process. Then that'll it'll make more sense.
Yeah.
Yeah, and then the final step is just turn all that data structure into text. Once we've done all of this work, getting it into text is actually the easy part.
Yeah, we will see. We'll see. In the beginning, I thought the load and the save was easy. It took me a long time. But,
yeah, we are under no illusions that this part's easy.
No. Let's say the learning curve is steep, but once you get the more the further you get, the easier it adds on.
Yeah.
That's the positive side of difficult stuff.
Yes, indeed. Yeah. In fact, I'm working with one of my folks at work who's building his own side project on Janaga.js, and so all of these little things that I figured out along the way and come up with these little patterns. Now I'm trying to teach those patterns, explain why they're necessary, and it's like, okay, I just want to get started. I just want to show something on a list on the screen, be able to add and delete. That's the only thing that I'm trying to do right now. I say, oh well, yeah. So you need this login, so you've got the user that's got the public key, and then you're going to need an authorization rule. So you want to make sure that the list belongs to some tenant that was created by that user, so that you can then authorize. And say, wow, okay. There's a lot to get started before you can actually just do the simple thing. So yeah, people often complain about. Like a Microsoft demo, like, hey, let's do this this really quick demo with see how easy it is to do entity framework stuff. But you say, oh, wait a minute, in a real application I would never do that, because here you just circumvented security, you just hard-coded a connection string right there. I say, no, I'm not going to do that. And oh, no, don't worry about that, you'll figure that out later. But then that turns into a whole set of patterns. So yeah, I haven't quite gotten where to enter the story.
Because it's actually so many little things together.
Mm-hmm.
And once you get the story of historical modeling, that's one thing, but the programming of the tools itself,
Mm-hmm.
That's still another level.
Yeah. Yeah, and most people will never see the code that we just looked at, and they will be happy for it.
Yeah, but once you understand that, I think it's a good feeling.
Mm-hmm.
I don't like to make things which I don't understand.
Yeah.
It makes me feel insecure.
Yeah, I'm with you.
Yeah, but more and more we have to accept black boxes.
Mm-hmm.
Before you could, programming was just two books like this.
Yeah.
And you could program.
Mm-hmm.
But that's when I was young, and when you were young. In meanwhile, situation has slightly changed.
Yeah.
Yeah.
All right. Well, I'm gonna go ahead and get into work. So yeah, next week we can continue look at how we do the existential conditions in here. Of course, I'm sure that you'll have some questions. We'll start with those, and we'll also see.
That might be.
Yeah.
Let me go through the session again with the source code at the side and see where we get.
All right.
Okay.
Sounds good.
Michael, thank you very much.
Thank you again.
See you next week.
See you then.